Okay, let's unpack this a bit. Imagine a single lens, right? One that lets you see how global health has just completely transformed over more than a century
Mm,
and reveals how something really fundamental like our heart health is profoundly shaped by these massive forces, urbanization, big shifts in our diet, even the kind of jobs we do.
yeah, it's all connected.
Today, we're taking a deep dive into the fascinating world of cardiovascular disease epidemiology. That's basically the study of how heart disease spreads and changes in populations,
Right. The patterns.
and the incredible, sometimes really surprising story of how our hearts, and actually entire societies, are evolving. And we're kicking off with a statistic that, honestly, it's pretty impactful.
It really is.
Cardiovascular disease is now the leading cause of death worldwide,
Number one.
more than infectious diseases and malnutrition combined, at least in recent history. That's not just a number. That's a massive, epoch-making shift in the human story, isn't it?
It absolutely is. And what's truly fascinating here, is that we're not just talking about individual health conditions, specific diseases.
No.
We're talking about a monumental shift in human history itself. It's what's been termed the epidemiologic transition.
Right, I've heard that term.
Think of it as humanity's journey, really, from battling these widespread acute infectious diseases, the plagues, the famines, to confronting chronic, often lifestyle-related conditions. And the heart finds itself right smack bang in the center of this new global health challenge.
So our mission today, and this is key for anyone wanting to truly grasp this field, is to really master this information.
Exactly. Like the elite professionals do, understand those critical
Yeah,
nuances.
we'll explore the fundamental biology, the heart's energy systems, its regenerative potential, which is fascinating in itself.
Very limited, but fascinating.
And then we'll zoom way out, right? Understand the broad global patterns of CVD, gig into the distinct stages of this epidemiologic transition.
Stage by stage.
Identify the major risk factors driving these changes across continents, and importantly, discuss what concrete actions can actually be taken.
What can we do about this massive, always evolving challenge that frankly touches every single one of us?
Okay, so to really get a handle on this global challenge, we absolutely have to start with the engine at its core, the human heart itself.
Makes sense. Start small, then go big.
So before we talk global disease patterns, let's get down to the absolute basics. How does the heart, this tireless muscle beating nonstop, how does it actually power itself? It's all about a molecule called ATP, right? Adenosine triphosphate.
That's the one, ATP. It's the fundamental energy currency for, well, pretty much all life. And the heart has a remarkably efficient and adaptable way of producing it constantly.
Constantly is the key word there.
Absolutely. The heart's amazing ability to just keep contracting, keep pumping blood, relies completely on an uninterrupted constant supply of ATP.
Right.
And producing this ATP requires the heart cells to generate a key molecular building block. It's known as acetyl coenzyme A, or you'll often hear it called acetyl-CoA.
Acetyl-CoA. Got it. Where does that come from?
Well, this acetyl-CoA can be derived from several different nutrient sources, and the heart is incredibly clever. It shifts its preference depending on what the body is doing, its current physiological state.
Okay, so it's flexible. What are those main fuel sources then? What does it prefer?
It's incredibly versatile. The primary sources, in terms of what it typically prefers to burn for fuel, are free fatty acids, basically fats circulating in your bloodstream.
Okay, fats first.
Then there's glucose, which is sugar. That comes from your blood, or it can be stored right there in the heart muscle itself as glycogen.
Stored sugar, right.
After those two main ones, it can also use lactate, certain amino acids, and even things called ketone bodies, especially if you're fasting for a while.
Ketones, yeah.
So when your heart needs energy, it first looks to those free fatty acids floating around, maybe from your last meal or your fat stores.
And the glucose, where's that from exactly?
Glucose comes directly from your blood sugar, yeah, but also from the heart's own internal stash, that myocardial glycogen. It breaks that down through a process called glycogenolysis.
Glycogenolysis. Okay, so these two main fuels, glucose and fatty acids, they're processed differently inside the heart cells, aren't they? Can you give us the sort of the high-level view of those pathways without getting totally lost in the biochemistry?
Absolutely. Let's keep it high level. The key thing to grasp is they take different routes, but they end up feeding the same energy-producing engine room in the cell.
Okay.
For glucose, it gets partially broken down first in the cell's main fluid area, the cytoplasm.
Right.
Then it moves into the mitochondria, the famous powerhouses of the cell. That's where it's fully converted into that crucial acetyl-CoA.
Mitochondria, got it. And the fats.
Free fatty acids, well, they're also processed a bit in the cytoplasm first, but then they get transported directly into the mitochondria to become acetyl-CoA. So, slightly different entry points, but both pathways are designed to efficiently deliver acetyl-CoA right where it's needed for major energy production.
And once that acetyl-CoA is inside the mitochondria, that's where the real ATP production magic happens. That's the main power generation stage.
That's exactly right. Once acetyl-CoA is formed inside the mitochondria, it enters what's known as the citric acid cycle. You might also know it as the Krebs cycle.
Krebs cycle. Yeah, I remember that from biology.
Right. And this cycle is like a central hub. It prepares the energy from acetyl-CoA for the final and most productive stage, oxidative phosphorylation.
Oxidative phosphorylation. That sounds important.
It is. It's the heart's primary, most efficient way of churning out massive amounts of ATP. Once that ATP is made, it moves out of the mitochondria into the main part of the cell, the cytoplasm.
Where the work happens.
Exactly. Where it's immediately put to work powering muscle contraction and all the other cell functions. And there's also a really clever feedback loop involved.
Yeah.
When the cell uses ATP, it produces adenosine diphosphate, or ADP. Think of it like a spent ATP molecule.
Okay.
That ADP acts as a signal. It drifts back to the mitochondria and basically tells them, hey, ramp up ATP production, we need more. It's how the heart instantly knows if its energy demand is increasing.
Wow. It sounds like an incredibly finely tuned system, constantly adapting. And you said the heart's fuel preference isn't static, right? It shifts depending on whether you've just eaten or if you're exercising.
Precisely. This fuel shifting is, well, it's a remarkable testament to the heart's metabolic flexibility. It makes sure it always has the best fuel for the job.
So give me an example, like when you're resting and haven't eaten.
Okay, yeah. In a fasted resting state, those circulating free fatty acids are definitely the dominant fuel source. They provide something like 70% of the heart's acetyl-CoA.
70% from fat. Wow.
But when you're in a fed state, say, after a meal, when your blood glucose and insulin levels are high, the heart cleverly shifts its preference. Glucose oxidation, burning sugar significantly increases, and burning fatty acids, that subsides. It switches gears.
So it's almost like it's intelligently picking the most readily available fuel at that moment.
Yeah.
What about when the heart's under more stress or working harder, like during exercise?
Good question. When there's increased cardiac work, maybe during intense exercise, or if the heart's under the influence of certain medications, or even facing conditions like low oxygen hypoxia,
Right.
or mild ischemia, which is reduced blood flow. All these situations prompt the heart to enhance its uptake and metabolism of glucose.
So it wants more sugar then?
It seems to prioritize it more, yeah. The heart also taps into its own stored glucose, remember, that glycogen, breaking it down quickly. And during exercise specifically, your body's circulating lactate levels go up.
Right, from the muscles.
And the heart actually becomes very efficient at grabbing that lactate and using it to make acetyl-CoA too. It adapts to the whole body's energy situation.
And what about stress? Like even just psychological stress. Does that mess with the heart's fuel choice too? It's amazing how deep that mind-body connection goes.
It absolutely does. When you experience something called beta-adrenergic stimulation, which happens during that fight-or-flight response, even from psychological stress.
Adrenaline.
Exactly. It causes an increase in circulating free fatty acids and boosts their metabolism. So in that stressed state, the heart tends to favor burning those free fatty acids over glucose.
Interesting. So stress makes the heart burn more fat.
It seems to shift the preference that way, yes. Our body's stress response can directly influence the heart's metabolic strategy, potentially making it more reliant on fats when you're feeling under pressure.
That's incredible. But what happens when things go really wrong? Like during severe myocardial ischemia, the kind of really bad blood flow reduction you'd see in a heart attack. How does that wreck this finely tuned energy system?
This is where the system can be critically disrupted, and it leads to major damage. Severe myocardial ischemia essentially cripples a key enzyme needed for efficient glucose burning in the cytoplasm.
Okay.
This forces the heart into a much less efficient kind of emergency backup mode called anaerobic glycolysis.
Anaerobic meaning without oxygen.
Precisely. Think of it like a high-performance engine suddenly having to run on really low-grade fuel, just sputtering along. This emergency pathway produces lactic acid instead of fully processing the glucose.
Lactic acid buildup, right.
And it's vastly less efficient. It generates significantly less ATP compared to the heart's usual aerobic, oxygen-rich metabolism. A huge drop in energy production.
And if you layer high levels of those free fatty acids on top of that severe ischemia, which you said can happen under stress, what's the result? Does it just get even worse?
That combination is particularly damaging. It creates a kind of perfect storm for the heart muscle.
Doesn't sound good.
No. High concentrations of circulating free fatty acids, especially when they hit a heart already struggling with severe ischemia, can further gum up the works of oxidative phosphorylation, that main ATP production line we talked about.
So less ATP again.
Even less, yeah. It causes the myocardial ATP levels to decline even more drastically, which directly impairs the heart's ability to contract properly. It just doesn't have the energy.
And there's more.
Yes, unfortunately. The breakdown products from these fatty acids, when they accumulate under these conditions, can actually become toxic.
Toxic? How?
They can damage the cell membranes, and even worse, they can be arrhythmogenic, meaning they can trigger dangerous, abnormal heart rhythms.
Wow. So the heart's running out of fuel, it's pumping less effectively, and it's generating toxic stuff that can cause arrhythmias.
Exactly. It's a vicious cycle, running on empty and poisoning itself, essentially.
Does the heart have any kind of immediate, like, emergency energy reserve?
Yeah.
A quick backup battery?
It does, but it's quite limited. Myocardial energy is stored in another molecule called creatine phosphate, or CP.
Creatine phosphate, okay.
This molecule is in a dynamic equilibrium with ATP, meaning it can quickly donate its energy to make more ATP. It acts as an immediate, readily available backup source, like a very small reserve tank.
But it doesn't last long.
No. In states of reduced energy availability or really high demand, these creatine phosphate stores are among the first things to get depleted. It's a clear warning sign that the heart is struggling to meet its energy needs.
And what kinds of conditions, maybe more chronic things beyond that acute ischemia, actually increase the heart's long-term energy needs, putting it at greater risk over time?
Several chronic factors can lead to persistently increased energy demands on the heart. Things like cardiac hypertrophy, that's the enlargement and thickening of the heart muscle, often due to things like high blood pressure.
Right, the heart works harder, it gets bigger.
Exactly. Also fibrosis, which is scarring and stiffening of the heart tissue. Tachycardia, a persistently fast heart rate. Increased wall tension, maybe because the heart chambers, the ventricles, have dilated or stretched out.
So it has to push harder.
It has to generate more force, yes. And even an increase in the levels of calcium inside the heart muscle cells, which affects how strongly they contract. All of these put additional ongoing strain on the heart's energy systems. They just demand more fuel constantly.
So if you have these chronically higher energy needs, maybe from high blood pressure or something, and you also have a reduced ability for the heart to get enough blood flow, that sounds like a recipe for disaster. Like progressive heart failure.
Precisely. That's a fundamental mechanism behind many forms of heart disease progression, when these increased energy needs are coupled with a reduced coronary flow reserve.
Meaning the blood vessels can't deliver enough extra blood when needed.
Exactly. The heart's ability to increase blood flow to meet higher demand is compromised, maybe due to blockages in the main coronary arteries or even problems with the tiny microvessels within the heart muscle itself.
Okay.
When that happens, an imbalance between myocardial ATP production and demand inevitably occurs. This imbalance leads to chronic ischemia, chronic energy starvation.
A constant energy deficit.
Yes, and that can then progressively worsen existing heart failure, or in some cases, directly cause its onset.
Yeah.
It's that vicious cycle again. Demand keeps outstripping supply, leading to a steady decline in heart function.
It's clear the heart is an incredible engine, but yeah, surprisingly vulnerable when its fuel supply or demand gets out of whack.
That brings us to a really fascinating and maybe hopeful question.
Okay.
If a heart is severely damaged, say by a big heart attack, can it actually repair itself? Can it regenerate?
Yeah.
Because when we connect this to the bigger picture of disease, understanding how the heart heals, or more often doesn't heal, that's crucial for future treatments, isn't it?
It is absolutely crucial. It raises that key question. Can we actually fix a broken heart biologically?
Yeah.
Unfortunately, for adult mammalian myocardial cells, the main pumping cells of our heart muscle, they're what we call fully differentiated.
Meaning specialized. Highly specialized, yes. They've honed their function to just pump blood tirelessly. But in doing so, they've largely sacrificed the ability to divide and make new copies of themselves. They have little to no regenerative potential.
So if they die in a heart attack, they're just gone.
Pretty much. Once damaged, say by that heart attack, The lost muscle tissue is overwhelmingly replaced by scar tissue, fibrous tissue, not new, functional muscle.
Scar tissue. That doesn't sound good for pumping.
It's not. That scar tissue can maintain some structural integrity. It holds the heart together, but it doesn't contract. It doesn't contribute to the heart's pumping action at all. And that often leads to a progressive decline in overall heart function over time. Heart failure.
So scar tissue replaces muscle. Not ideal.
Yeah.
But I feel like I've heard about some glimmer of hope, some research, especially looking at younger hearts. Is there something different going on there?
That's correct, and it's a very active, exciting area of research. There's compelling evidence that the immature mammalian heart, think newborn mice, maybe even human infants, does possess some limited regenerative potential.
Really? Newborns?
Yes, but, and this is the frustrating part, this remarkable capacity rapidly becomes constrained, shut down essentially, as the heart matures and has to deal with the increasing demands of growth and workload.
Why? Why does it lose it?
It's almost as if the sheer metabolic demands, the constant need to pump, quickly suppresses this early regenerative ability. It prioritizes function over repair, maybe. Unlocking why that happens and if we can reverse it is a major scientific quest right now.
So if the adult heart doesn't naturally regenerate well, what's the focus of current research? Are scientists trying to trick the heart cells into dividing again, turn back the clock somehow?
Exactly. That's a good way to put it. Considerable effort right now is being devoted to evaluating various cutting-edge approaches. They're designed to try and transiently release these natural breaks, these constraints on regeneration. It involves things like manipulating specific genes or signaling pathways within the heart cells, maybe introducing special progenitor cells that could turn into new muscle, or even creating a more supportive environment, biologically speaking, within the damaged heart tissue to encourage repair. It's really about finding that on switch for regeneration that seems to get turned off as we mature.
And if that research is successful, what's the ultimate potential? What could that mean for the millions of people living with damaged or failing hearts?
Well, the success of these kinds of approaches would offer the incredibly exciting possibility of actually truly reconstructing an infarcted or failing ventricle.
Reconstructing it, like growing new muscle.
Potentially, yes. Imagine being able to regrow functional heart muscle after a massive heart attack, effectively restoring its pumping power rather than just managing the symptoms of a heart that's slowly failing.
It would be revolutionary.
It would be transformative. It's really a frontier with immense potential to revolutionize how we treat heart disease, moving beyond just slowing the decline to potentially reversing the damage and restoring heart health. It's a profound vision for the future of cardiology.
That's a powerful and hopeful vision for individual heart health.
Yeah.
Okay, but now let's pivot. Let's zoom out dramatically from the microscopic world of heart cells and energy.
Right, to the big picture.
To the macroscopic, sweeping changes across entire human populations. We've set the biological stage. Now let's look at the global scale. And here's where it gets really interesting and reveals this surprising reversal in what kills us. Until around 1900, what do you think was killing most people worldwide? Was it anything like today's big health concerns?
Oh, not at all. From a historical perspective, the landscape of global mortality was, well, vastly different, almost unrecognizable compared to today.
How so?
Before 1900, infectious diseases, think devastating waves of tuberculosis, dysentery, cholera, influenza, along with pervasive malnutrition, were overwhelmingly the leading causes of death. Life was often brutally short, precarious, dominated by battles against invisible microbes, and the constant struggle just to get enough food.
And heart disease back then.
In that era, cardiovascular disease was a comparatively minor player. It accounted for less than 10% of all deaths. It just wasn't the major killer it is today. It was a world fundamentally shaped by infection and famine.
Okay, less than 10%. And what's the reality today? In stark contrast to that history,
Right.
How has that global health landscape been totally flipped?
The reality today is nothing short of a dramatic reversal. It's a testament in some ways to global progress, but it brings entirely new challenges.
Right.
In 2017, for instance, cardiovascular disease accounted for an astounding 17.8 million deaths worldwide.
17.8 million.
That makes it unequivocally the most common cause of death globally. It represents a staggering 32%, nearly a third of all deaths.
A third of everyone.
And what's particularly striking and really significant for understanding the current situation is that this high rate is now alarmingly similar in both high-income countries, the wealthy nations, and in low- and middle-income countries, the LMICs. This parity, which is a relatively recent phenomenon, signals a truly global shift. CVD is no longer just a disease of affluence.
This global rise in CVD, you said earlier, it isn't random. It's part of this bigger pattern, this unprecedented transformation that experts call the epidemiologic transition.
Exactly.
It's driven by these huge forces, industrialization, urbanization, and the profound lifestyle and demographic changes that just inevitably come with them.
Precisely. This epidemiologic transition is a truly global phenomenon. It's unfolding, maybe at different speeds, but in every part of the world, among all races, ethnic groups, and cultures. It fundamentally reshapes the health profile of populations as they develop economically and socially.
And you mentioned stages.
Yes. This transition is typically divided into 4 basic stages, each characterized by distinct patterns of disease and mortality. And there's now an emerging 5th stage becoming apparent in some countries, signaling new, maybe even more complex challenges.
Okay.
Understanding these stages is absolutely key to grasping the complex, varied global patterns of CVD we see today. It's the framework for making sense of it all.
All right, let's break down these stages then. Take us back in time. Stage 1, the age of pestilence and famine. What did life and unfortunately death look like then?
Stage 1 paints a pretty stark picture of human existence for most of history. It's characterized by the predominance of malnutrition and infectious diseases, those widespread outbreaks we talked about, TB, cholera, influenza being the primary relentless causes of death.
So infections and not enough food.
Basically, yes, you'd see very high rates of infant and child mortality. It was tragically common, though these high death rates were often offset by equally high fertility rates, so populations didn't necessarily decline.
And life expectancy.
Incredibly low, typically hovering around 30 years. Just think about that.
30. Wow.
And in terms of cardiovascular disease back then, as we said, a minor contributor, less than 10% of deaths.
Right.
What CVD did exist mostly took the form of rheumatic heart disease.
From infections like strep throat.
Exactly. And cardiomyopathies, heart muscle diseases, often resulting directly from severe untreated infections or chronic malnutrition. And interestingly, even today, maybe 10% of the world's population, primarily in certain very low-income, isolated regions, still remain largely in this challenging first stage.
That's sobering. So what happens as a society starts to climb out of that? Stage 2, the age of receding pandemics. What changes?
Okay, stage 2 is where you see the first real signs of sustained progress, a tangible shift in human well-being. Per capita income starts to rise, people generally have more resources, and with that, life expectancy begins to increase noticeably.
Things are getting better.
Definitely. This stage is primarily marked by the emergence and strengthening of public health systems. This brings critical advancements like cleaner water supplies, better sanitation, improved overall nutrition.
Basic public health infrastructure.
Foundational stuff, yeah. And these improvements combine to drive down deaths from infectious diseases and malnutrition quite dramatically. Infant and child mortality also declined precipitously. That's a huge gain in human life right there.
But there's a catch, isn't there? As the old killers recede.
There is. This is the crucial turning point. As those traditional killers fade, deaths due to cardiovascular disease begin to increase significantly. They rise to somewhere between 10% and 35% of all deaths.
So CVD starts to emerge as a bigger problem. What kinds?
The predominant forms of CVD you'd see are still some rheumatic valvular disease, that legacy of past infections. But now you see the clear emergence of hypertension, high blood pressure becomes more common, coronary heart disease starts to appear, and stroke.
Stroke too.
Yes, and interestingly at this stage, strokes are often predominantly hemorrhagic bleeding in the brain rather than ischemic, caused by clots, which becomes more common later. And today, almost 40% of the world's population is currently estimated to be in this dynamic, transitional second stage.
40%. So a huge chunk of the world is right in that transition now. It sounds like a mixed blessing then, escaping the old scourges but facing new chronic challenges. That takes us to stage 3, the age of degenerative and man-made diseases. What defines this phase?
Stage 3 is distinguished by a really profound and generally irreversible shift. Mortality from non-communicable diseases, primarily cardiovascular disease, but also things like cancers unequivocally surpasses mortality from malnutrition and infectious diseases. They become the main killers.
And lifestyle changes accelerate here.
Dramatically. You see a significant increase in overall caloric intake, especially from animal fats, processed foods, coupled with a general decrease in physical activity because work becomes more sedentary, leisure time becomes less active.
Right. Cars, TVs, office jobs.
All of that contributes. These shifts lead to the widespread emergence and prevalence of conditions like hypertension, which becomes even more common, and atherosclerosis, the hardening and narrowing of arteries due to plaque buildup.
So the biological groundwork for heart attacks and strokes is laid.
Exactly. With these shifts, average life expectancy now typically surpasses 50 years. But the consequence is that somewhere between 35% and 65% of all deaths in populations in this stage can be directly traced back to CVD.
35 to 65%. That's huge.
It is. Coronary heart disease and stroke are highly prevalent. And importantly, CHD deaths, heart attacks typically exceed stroke deaths by a significant ratio, often 2 to 1 or even 3 to 1 in this stage. And roughly 35% of the world's population currently falls into this third chronic disease-dominated stage.
Okay, that sounds like where many industrialized nations were maybe in the mid-20th century when CVD mortality peaked. What defines the fourth stage then? The age of delayed degenerative diseases. Is this where we finally start to see some progress against heart disease?
Yes, stage 4 is where we see a crucial turning of the tide, although CVD is still a major player. In this stage, cardiovascular disease and cancer remain the major causes of morbidity and mortality. CVD still accounts for a significant chunk, often around 40% of all deaths.
Still high,
But what profoundly characterizes this stage is a decline in the age-adjusted CVD mortality rates.
age-adjusted, meaning accounting for the aging population.
Exactly. The risk for a person of a given age starts to go down, and this progress is the result of concerted, effective preventive strategies. Think widespread public health campaigns against smoking, better population-level blood pressure control.
And better treatments.
Absolutely crucial. Significant advancements in acute hospital management, much better care for heart attacks and strokes when they happen, and major technological breakthroughs like bypass surgery, angioplasty, effective medications like statins.
So people are surviving events they wouldn't have before.
Yes, and they're preventing them more often, too. The forms of CVD are still the familiar ones: CHD, stroke, congestive heart failure. But these conditions are now affecting older and older individuals as people live longer lives, often free from CVD until much later. About 15% of the world's population is currently in this stage, or maybe just transitioning out of it.
Transitioning out of it into that concerning fifth stage you mentioned,
Yeah.
the age of inactivity and obesity. What's happening there that could actually reverse some of this hard-won progress?
Indeed, stage 5 is a crucial and, frankly, potentially troubling emerging trend. It could threaten to reverse decades of progress, particularly in the industrialized world, but also increasingly in rapidly developing nations.
What's driving it?
We're seeing this continued, maybe even accelerating decline in physical activity, sedentary jobs, screen time, car culture, coupled with an ongoing increase in total caloric intake. Food is often abundant, cheap, calorie-dense, maybe nutrient-poor. This combination has resulted in a truly global epidemic of overweight and obesity.
And the knock-on effects.
Consequently, rates of type 2 diabetes, mellitus, hypertension, and lipid abnormalities, those unhealthy cholesterol and fat levels are rising alarmingly. And what's really concerning is seeing these trends even in children.
Yeah, that's scary for the future.
It is. Additionally, the rate of decline in smoking, which was such a major public health success story for decades, seems to be leveling off or even reversing in some groups.
So progress is stalling there, too.
It seems to be. The critical significance here is that if these adverse risk factor trends, obesity, diabetes, inactivity, stalled smoking cessation, continue unchecked, the age-adjusted CVD mortality rates that had fallen so impressively during the fourth phase could potentially begin to increase again in the coming years. That would be a disturbing reversal.
Wow, going backwards after all that progress.
It's a real risk. This stage is still characterized by CHG, stroke, heart failure, peripheral vascular disease, but potentially affecting an ever-growing and maybe even younger population due to these pervasive risk factors.
Okay, so these stages lay out a kind of general roadmap for how nations' health profiles change. But it doesn't happen uniformly everywhere, does it? How has this actually played out in different parts of the world? You mentioned the United States is a useful reference point. Can you trace its journey through these stages?
Yeah, the United States provides a pretty clear, well-documented example of this whole transition. Before 1900, the U.S. was largely agrarian, definitely in stage 1, the age of pestilence and famine. Infectious diseases, malnutrition, those were the big killers, keeping life expectancy quite low.
Okay, stage 1.
By the 1930s or so, the country had clearly progressed into stage 2, the age of receding pandemics. Public health infrastructure started getting established vaccinations, sanitation, cleaner water. This led to dramatic declines in infectious disease deaths.
What?
But at the same time, you had rapid urbanization, industrialization, and big lifestyle changes, starting diet changing, activity levels dropping, and this contributed to a noticeable rise in cardiovascular disease mortality rates. They reached around 390 deaths per 100,000 people back then.
So CVD starts its climb. And after that, into stage 3, where heart disease really took hold in the U.S.
Exactly. Between roughly 1930 and 1965, the U.S. fully entered stage 3, the age of degenerative and man-made diseases. Infectious disease mortality rates just plummeted, becoming a relatively minor threat, less than 50 per 100,000.
Okay.
But in stark contrast, CVD mortality rates peaked during this period. Urbanization continued relentlessly, and lifestyle factors like higher fat diets, processed foods, less physical activity, and critically, widespread tobacco use became deeply embedded in American culture.
The Mad Men era.
Who'd say that, yeah. Then, from about 1965 to around the year 2000, the country moved into stage 4, the age of delayed degenerative diseases. This period was really transformative for heart health.
How so? What changed?
We saw the widespread introduction of new effective treatments, powerful drugs for blood pressure and cholesterol, surgical innovations like bypass, plus sustained preventive measures and massive public health campaigns, especially against smoking.
Right, the anti-smoking push was huge.
Yeah, huge impact. All this led to substantial, consistent declines in those age-adjusted CVD mortality rates. People were living longer, healthier lives on average, and CVD was increasingly becoming a disease of older age.
Okay, so the U.S. saw this significant, steady drop in CVD deaths for decades. A real success story in many ways. But what about after 2000? Are we seeing signs of that concerning stage 5 kicking in, where progress might be slowing or even reversing?
Indeed. It's a complex picture now. Post-2000, the decline in the age-adjusted CVD death rate, which had been around 3% per year in the 70s, 80s, then slowed to 2% in the 90s, actually showed a renewed, faster decline of 3–5% per year in the first decade of the 2000s. That sounds good.
It does, but
There are significant signals that the U.S. is now firmly entering, or maybe well into, that crucial fifth phase, the age of inactivity and obesity. It's characterized by this complex interplay of competing trends.
competing trends, like good versus bad.
Exactly. On the negative side, we're seeing this persistent, really concerning increase in the prevalence of type 2 diabetes and obesity. That's a massive headwind. The rate of smoking decline, as we mentioned, seems to be slowing significantly, and progress on detecting and treating hypertension seems to have plateaued somewhat.
Okay, those are the bad trends. Any good news?
Yes, conversely, positive trends include continued declines in population-wide cholesterol levels, possibly due to diet changes, and definitely increased use of effective statin medications.
So it's a tug of war.
It really is. The delicate balance of these opposing forces, the rising tide of obesity and diabetes versus better cholesterol management and treatments, will critically determine the future path of CVD in the U.S. and likely in many other developed nations facing similar challenges.
That's a comprehensive look at the U.S. How do other high-income countries, the HICs, which make up about 15% of the world's population, compare? Do they all just follow the same script?
Many high-income countries have indeed proceeded through these 4 stages, following a pattern pretty similar to the United States, yeah. In most of these countries, coronary heart disease, CHD, is generally the dominant form of CVD. Rates are typically 2 to 5 times higher for CHD than for stroke.
But you said there were variations.
Oh yes, some interesting and significant variations. For example, North America, Australia, and the Central and Northwestern European HICs, they tended to experience really significant initial increases in CVD rates, followed by rapid, quite impressive declines later on.
Okay, and others.
But countries in Southern and Central Europe saw a more gradual rise and fall. It suggests maybe different underlying lifestyle patterns, different timing of dietary changes, or maybe different healthcare system responses.
Any specific countries that really stand out as having unique patterns?
Certainly. Countries like Portugal, Spain, and notably Japan, they never actually reached those extremely high CVD mortality rates that were seen in the United States, or, say, Finland in the peak years.
Really? Why not?
Their coronary heart disease mortality rates remained comparatively low, staying below 200 per 100,000. Western Europe also shows a very clear north-south gradient in CVD rates.
Or itself?
Yeah, the highest rates historically were found in northern countries like Finland, Ireland, Scotland, and the lowest rates were in the Mediterranean countries, France, Spain, Italy, often attributed, at least partly, to the traditional Mediterranean diet.
Right. Olive oil, fish, vegetables.
Exactly. And Japan in particular really stands out among the HICs. This is most likely due to the unique traditional dietary patterns of its population, historically emphasizing fish, vegetables, soy, rice, much lower saturated fat intake.
So diet made a big difference.
It seems so. While stroke rates did increase dramatically in Japan in the past, partly linked to high salt intake and hypertension, CHD rates didn't rise nearly as sharply as in the West. However, there's a caveat here too. Japanese dietary habits are now undergoing substantial westernization, more meat, more dairy, more processed foods. And this is being reflected in a concerning increase in average cholesterol levels among its population. So even Japan isn't immune to these global shifts.
Okay, that covers the HICs. Now let's talk about the low and middle income countries, the LMICs. You said they have 85% of the world's population, so they are truly driving the global changes in the CVD burden now. But it's clearly not a single uniform story across these incredibly diverse regions, is it?
You're absolutely right. The picture in LMICs is incredibly diverse, incredibly complex. The patterns are shaped by this dynamic interplay of deep cultural differences, unique secular trends, these long-term changes unfolding over decades.
Right.
And also the varying responses at the country level regarding both public health infrastructure, is it strong or weak, and the availability of advanced medical treatments.
So very context dependent.
Very. And while communicable diseases, infections, still pose a major health challenge in many of these regions, cardiovascular disease has unequivocally emerged as a significant and often rapidly accelerating health concern right alongside them. It's often called the double burden of disease.
Double burden, right.
Yeah.
Fighting old and new problems at once.
Exactly. A common observable trend in most LMICs, though, is an urban-rural gradient for conditions like CHD, stroke, and hypertension.
Meaning higher rates in cities.
Consistently higher rates found in urban centers, yes. This is likely due to the faster adoption of modern, often less healthy, lifestyles, processed foods, sedentary work, more stress compared to more traditional, often more physically active rural areas.
Okay, so let's explore that regional heterogeneity within the LMICs, starting with, say, East Asia and the Pacific. What's the story there? A huge dynamic region.
It really is. The East Asia and Pacific region seems to be kind of straddling stages 2 and 3 of the epidemiologic transition. They're experiencing rapid, sometimes very uneven economic development and lifestyle change.
Uneven, okay.
In China, for example, CVD is now a major cause of death, definitely stage 3 territory in many ways. But notably, similar to Japan's historical pattern, stroke causes significantly more deaths than coronary heart disease, often at a ratio of about 3 to 1.
3 times more stroke deaths than heart attack deaths. Why?
It's often linked, at least partly, to the very high prevalence of undiagnosed and untreated hypertension in the region. High blood pressure is a major driver of stroke, especially hemorrhagic stroke.
Right, and other countries in that region.
Well, contrast China with countries like Vietnam or Cambodia. They seem to be just beginning to emerge from stage 1, the age of pestilence and famine. It shows that the transition is highly asynchronous, happening at very different speeds, even within the same broad geographic region. Some populations are battling the old scourges while their neighbors are facing the new ones.
Wow, okay. And the Middle East and North Africa, how are they progressing?
The Middle East and North Africa also appear to be firmly entering, or maybe well into, stage 3. They're experiencing increasing life expectancy, which is good news.
Yeah.
But their CVD death rates are now alarmingly close to, or in some cases just below, those of high-income countries. This signals a very rapid and concerning shift in their health profile. It seems driven strongly by changing diets, big reductions in physical activity, and really rapidly rising rates of obesity and diabetes in many countries there.
So a very fast transition there.
Yeah.
How about Latin America? Big continent, lots of diversity there too, I imagine.
Generally, Latin America appears to be mostly in stage 3, where non-communicable diseases like CVD dominate the mortality figures. However, just like East Asia, there's vast regional heterogeneity even within this continent. Meaning some areas, maybe more rural or less developed parts, might still look more like stage 2, while some major urban centers or more developed nations might be progressing into stage 4, showing declines in age-adjusted rates. It reflects those very paces of development, urbanization, lifestyle changes, and also socioeconomic disparities in different public health efforts across the region.
Okay. And Eastern Europe and Central Asia, you hear some particularly concerning statistics about CVD from that region.
Indeed. Unfortunately, the Eastern Europe and Central Asia region seems to be firmly stuck in the peak of stage 3. They exhibit the highest CVD death rates globally. That's a truly alarming statistic.
Highest in the world.
Yes. And crucially, unlike some HICs where CVD is increasingly becoming a disease of the elderly, heart disease in this region has a significant, devastating effect on working age populations, people in their 40s, 50s, 60s.
Wow, that's young.
It is. And this not only causes immense individual suffering and family tragedy, but it also leads to substantial economic and social costs, reduced productivity, loss of skilled workers, huge healthcare burdens. It's a major brake on development.
What about South Asia, particularly India? That's another massive population undergoing incredibly rapid change.
South Asia, and yes, India accounts for the largest part of its population, is experiencing an alarming and very rapid increase in heart disease. The transition there appears to be following a more Western-style pattern than, say, East Asia.
Meaning more heart attacks than strokes.
Yes, coronary heart disease seems to be emerging as the dominant form of CVD, driven by familiar risk factors. Unhealthy diets migrating towards more fat and sugar, rising physical inactivity, rapidly increasing rates of diabetes and obesity.
But are the older problems gone?
Not entirely. It's important to note that rheumatic heart disease, that legacy of past infections and poverty, continues to be a major cause of illness and death in South Asia, especially among younger people and the poor. This highlights that double burden, again, aspects of the earlier stages persisting, even as the new modern challenges like CHD explode onto the scene.
A really complex health environment. And finally, sub-Saharan Africa. Vast region, many different situations there too, I assume. Where does it generally stand in this global health story?
Sub-Saharan Africa, as a broad region, largely remains in stage 1 of the epidemiologic transition, the age of pestilence and famine.
Still stage 1.
For the most part, yes. Consequently, infectious diseases, HIV/AIDS, malaria, tuberculosis, along with widespread malnutrition, are still the dominant health challenges and causes of death.
And CVD there.
Rheumatic heart disease, linked to those earlier infections, remains an important cause of CVD morbidity and mortality. Hypertension is also increasingly recognized as a major, often undiagnosed problem. While some urban centers, particularly in countries like South Africa, are definitely showing signs of entering stage 2 or even stage 3, the vast majority of the region is still grappling primarily with the diseases of poverty and underdevelopment. The transition is happening much more slowly there overall.
Okay, so what explains this incredibly wide variation, this heterogeneity among all these LMICs?
Yeah.
It's clearly not just about economic development level, is it? There must be more going on.
You're absolutely right. Several complex, intertwined factors contribute significantly to this heterogeneity. Firstly, as we've just discussed, different regions, countries, even communities within countries are simply in different stages of the epidemiologic transition. They're progressing at wildly different rates due to their unique historical paths, social structures, political stability, and economic trajectories.
Okay, different starting points, different speeds, what else?
Secondly, there are just vast differences in lifestyle and behavioral risk factors across these diverse populations. These are shaped by unique, deep-rooted cultural practices, centuries-old dietary norms, some protective, some not, and the specific levels of economic development and market integration, which influences food availability and work patterns.
Culture and tradition matter a lot.
Immensely. Thirdly, emerging research is increasingly suggesting that underlying racial and ethnic differences might lead to altered susceptibilities to various forms of cardiovascular disease or risk factors like hypertension. That adds another layer of biological complexity we're still trying to fully understand.
Genetics playing a role, too.
Potentially, yes, interacting with environment. And finally, a really crucial practical point. For many countries in these regions, particularly the lower income ones, accurate, comprehensive, countrywide data on cause-specific mortality and morbidity are still incomplete or difficult to obtain reliably.
You just don't have the full picture.
Often we don't. This lack of robust, high-quality data can obscure the true scale and nature of the problem, making precise comparisons difficult and hindering the design of effective targeted interventions. It's a major hurdle we need to overcome to really combat this global epidemic effectively. You can't fight what you can't accurately measure. And this sweeping narrative, these stages, these risk factors, it isn't just theory or anecdote. It's built on a massive amount of continuously refined data. The Global Burden of Disease Study, the GBD, is a truly monumental international effort.
Right, I've seen references to GBD everywhere in health research.
It's foundational. It constantly refines its estimates, drawing on more and more data sources, improving its methods. It gives us the clearest picture yet of what's happening with health globally, and it enables us and policymakers to truly master the precise scope of this global challenge. It's a vital tool for anyone serious about understanding global health dynamics.
So how did the GBD study, maybe specifically the 2017 update you mentioned earlier, how did that refine our understanding of these global CVD trends? What were the major updates or changes, and how do they impact the overall estimates?
GBD 2017 brought several important methodological improvements and integrated a huge amount of new data, significantly refining our picture of global health. Some key updates included, for instance, an independent estimation of population size and fertility rates for every country.
Okay.
They integrated over 127 new country years of vital registration data, actual death certificates, plus new verbal autopsy data.
Verbal autopsy, what's that?
That's where, in regions without formal death registration, trained interviewers gather information about the symptoms and circumstances of a death from family members to try and determine a probable cause. It's crucial for getting data from many LMICs.
I see. Important work. What else did GBD 2017 do?
They also made crucial revisions to deaths that might have been previously misclassified to conditions like dementia, Parkinson's disease, or even atrial fibrillation, ensuring more accurate attribution to the underlying cause, which might be CVD. And they even added new specific diseases to their analysis, like non-rheumatic calcific aortic valve disease and degenerative mitral valve disease, getting more granular about cardiac conditions beyond just broad categories.
So more data, better methods, more specific diseases. What was the overall impact of these refinements on our understanding of CVD's global burden? Did it confirm the picture or change it significantly?
It largely reinforced the overwhelming and still growing impact of CVD globally. It confirmed it as a monumental challenge. Overall, cardiovascular disease accounts for that 32%, nearly a third of all deaths worldwide. And crucially, this number is unequivocally expected to continue increasing, driven primarily by global population growth and population aging. More people living longer, reaching ages where CVD risk is higher.
Okay, 32% overall. Drilling down into specifics, what about coronary heart disease, CHD specifically, heart attacks?
CHD alone accounted for 16.0% of all global deaths in the 2017 analysis. That's 1 in 6 deaths worldwide. It also represented the largest single portion, 10% of global years of life lost, YLLs, which measures premature mortality, and 7% of disability-adjusted life years, or DALYs, which combine premature death and years lived with disability.
So CHD isn't just killing people, it's causing a huge amount of suffering and loss of healthy, productive life years before death, too.
Exactly. It's a massive burden in both mortality and morbidity.
And what about stroke? We know that's the other major pillar of CVD, and you said it's particularly big in some regions like East Asia. How did its ranking change?
Stroke's position in the global mortality landscape shifted significantly with the GBD 2017 update. It actually moved up from being the third leading cause of death globally to become the second leading cause.
The second only to CHD.
Second overall, yes, accounting for a significant 11.0% of all deaths worldwide. It also remained the third largest contributor to global YLLs at 7% and daylines at 5%.
So if you combine CHD and stroke.
If you combine them, coronary heart disease and stroke together account for more than a quarter, over 27% of all deaths worldwide. It just underscores their immense collective burden as the twin giants of the global CVD epidemic.
That's a truly staggering proportion. And you mentioned earlier that the burden of stroke seems particularly heavy in LMICs. Can you quantify that disparity compared to HICs? Is it really that much worse?
The disparity is stark, yeah, and it really highlights a critical global health equity issue. The GBD data showed that the impact of stroke, measured in terms of DALYs and mortality rates, is more than 3 times greater in low and middle income countries compared to high income countries.
3 times worse?
More than 3 times the burden per person, yes. It means that for every person significantly impacted by stroke in a wealthy nation, there are effectively 3 in a developing nation, often with far fewer resources for prevention, acute treatment like clot-busting drugs, or rehabilitation. This makes stroke a major urgent target for global health interventions and resource allocation, specifically aimed at LMICs.
Given that LMICs have 85% of the world's population, it makes logical sense that they are now largely driving the overall global CVD rates and trends, even if HICs are further along in their epidemiologic transition. How many actual CVD deaths occurred in LMICs versus HICs in 2017? Just to put the sheer scale in perspective.
The absolute numbers are really illuminating, and they underscore exactly where the bulk of the global burden now lies. In 2017, GBD estimated more than 14 million, specifically 14.4 million cardiovascular deaths occurred in low and middle income countries.
14.4 million in LMICs.
and in HICs.
That contrasts sharply with 3.3 million CVD deaths in high-income countries during the same year.
Wow, more than 4 times as many deaths in LMICs.
Yes, that vast numerical difference really emphasizes that while HICs have made progress in reducing their age-adjusted rates, the sheer volume of population in LMICs means they now bear the overwhelming majority of the absolute burden of CVD deaths globally. And this leads to that fascinating and often confusing point about age-adjusted death rates versus the raw number of deaths. You said that globally, the number of CVD deaths actually increased significantly between 1990 and 2017 by almost 50%.
49% increase in the number of deaths, yeah.
But during that same period, the age-adjusted death rates actually decreased by about 30%. How do we square that? It feels counterintuitive. More deaths, but lower risk.
This is a critical nuance to grasp, and it shows the powerful, often overwhelming impact of global population dynamics demography. Between 1990 and 2017, yes, the overall number of CVD deaths worldwide increased dramatically by that 49%.
Okay.
However, during that very same period, the age-adjusted death rates, which, remember, mathematically remove the effect of changes in population size and age structure, giving us a clearer picture of the actual underlying risk per person at a given age, those rates actually decreased substantially by 30.4%.
So what does that mean in plain English?
It means that despite real commendable progress in treating and preventing heart disease per person, our medical interventions, public health campaigns are working to some extent, making individual lives longer and healthier on average.
Right.
The sheer scale of global population growth, particularly in developing nations, combined with population aging worldwide, more people living into older age, is creating this tidal wave of new cases and, consequently, a rising total number of deaths.
So medical gains are being outpaced by demographics.
In terms of absolute numbers, yes. It's like we're running faster, medically speaking, but the finish line, represented by the total number of people at risk, is moving away from us even faster due to population growth and aging. It highlights that even our successes come with new demographic challenges and require continuous scaled-up efforts just to keep pace, let alone get ahead globally.
So even with medical progress making individuals healthier for longer, more people are simply reaching the age where CVD becomes prevalent, especially in LMICs, leading to that rise in total deaths. What are the future predictions then? For CVD trends in both HICs and LMICs, are these divergent trends expected to continue?
For the high-income countries, the general expectation is that the modest decline in age-adjusted CVD death rates, which began maybe 50, 60 years ago, will probably continue, but the rate of decline seems to be slowing significantly. We might be hitting diminishing returns on some existing strategies or facing those headwinds from stage 5 risk factors.
But what about the total numbers in HICs?
Despite slowing rate declines due to the continued aging of their populations, the baby boomers getting older, etc., these HICs are still projected to see an increase in the prevalence of CVD, more people living with heart conditions, and likely an increase in the absolute number of CVD deaths, even if the per-person risk at a given age is slightly lower. Their populations are also growing, partly fueled by immigration from LMICs, but their overall share of the world population will likely continue to shrink, putting even more demographic weight on LMICs.
And for the LMICs, which are still undergoing these massive demographic shifts, what does the future hold for their heart health? It sounds potentially grim.
For LMICs, the situation is definitely more complex and potentially more challenging, yes. Significant portions of their populations, billions of people, have entered stage 3, with some larger middle-income countries even progressing into stage 4. This means rising chronic disease burdens are already baked in.
And demographics amplify this.
Enormously. Changing demographics play an overwhelming role in these future projections. Just consider the stark contrast. Between 2010 and 2017, the population growth rate in Eastern Europe and Central Asia was a relatively modest 1.1%. But in South Asia, during the same period, it was a dramatic 11% growth.
Huge difference.
That differential growth alone will profoundly shape the future burden of CVD. As these huge populations in Asia, Africa, and Latin America continue to grow in age, and as more people adopt urbanized, often sedentary lifestyles with westernized diets, the sheer numbers of individuals entering the high-risk age groups for CVD will skyrocket. It's going to place immense, potentially unsustainable pressure on their healthcare systems.
And what about the economic impact of this ballooning CVD burden, particularly in LMICs? Beyond the terrible human suffering, are we talking about a significant break on economic development?
The projected economic impact is truly substantial and deeply concerning for many developing nations, even if we make a very optimistic assumption that current CVD risk factor levels don't get any worse, which is unlikely.
Right, probably wishful thinking.
Probably. Even then, many countries, particularly large ones like India or countries like South Africa with high existing burdens, are predicted to see a very large number of working-age people, specifically those between 35 and 64 years old, die prematurely from CVD over the next few decades.
Losing people in their prime productive years.
Exactly. And alongside this premature mortality, there will be an increasing level of morbidity. Millions more people living with debilitating heart conditions like heart failure or stroke disability. This hits productivity, racks up huge healthcare costs, strains social support systems, and ultimately acts as a significant drag on overall economic growth. It's not just a health crisis. It's a profound economic development challenge that can trap nations in cycles of poor health and poverty by eroding their human capital and diverting scarce resources away from education or infrastructure.
Okay, so that's the sobering global picture and the trajectory. Let's get back to the why. What's fundamentally behind these global variations and the alarming trends we're seeing? You said it largely comes down to risk factors, what we do, what we eat, how our bodies respond. From that big picture, ecological perspective, looking at whole populations, how well do the known risk factors actually correlate with the observed mortality rates? Are they really the main drivers?
Yes, they absolutely are. These ecologic analyses, the ones looking at population-level data rather than individuals, consistently demonstrate very high correlations between the expected mortality rates based on risk factor prevalence and the actual observed mortality rates for the three main conventional cardiovascular risk factors: smoking, elevated serum cholesterol levels, and hypertension, high blood pressure.
So the data lines up.
It lines up very well. This strongly suggests that a large part of the regional variations we observe in CVD rates around the world are indeed directly attributable to differences in the prevalence and the impact of these well-established modifiable risk factors. They are truly the fundamental drivers of this modern epidemic.
All right, let's delve into those drivers then, starting with the behavioral ones. Tobacco use, clearly a massive one, a habit deliberately spread globally by industry for decades. What's the sheer scale of its impact on CVD worldwide now?
The scale is, well, it's staggering and deeply troubling, even with the progress made. Worldwide, it's estimated there are over 1.4 billion people who use tobacco in some form: cigarettes, cigars, smokeless tobacco, etc.
1.4 billion.
And this habit currently causes about 7.1 million deaths annually from any cause. That represents nearly 13%, 12.7% of all deaths worldwide. Critically, for our discussion, a huge portion of these 2.6 million deaths per year are directly related to cardiovascular disease.
So tobacco is a primary instigator of heart attacks, strokes.
Absolutely. Heart attacks, strokes, peripheral artery disease, aortic aneurysms. Tobacco smoke damages blood vessels, promotes clotting, raises blood pressure, worsens cholesterol profiles. It's just toxic for the cardiovascular system.
And are smoking rates uniform across different income levels? Or are there disparities there too? Is it a bigger problem for the rich or the poor?
Not uniform at all. There are distinct patterns, and they're maybe a bit counterintuitive based on common perceptions. The populations of high-income countries, despite decades of public health campaigns, still smoke, on average, at almost double the rate of people in low-income countries.
Really? HICs smoke more.
The rates are about 21.6% in HICs versus 11.2% in low-income countries, according to recent data. Middle-income countries fall somewhere in between, with a smoking rate of 19.5%, which is very close to the global average of 19.2%.
Why is it higher in HICs still?
It likely reflects historical patterns. Smoking became widespread earlier in developed nations, and maybe greater affordability despite higher taxes. It suggests that even with strong public health efforts, tackling deeply ingrained smoking behavior remains a challenge everywhere, but especially where it got established first. It also highlights that as LMICs develop economically, there's a huge risk their rates could rise towards HIC levels if strong prevention isn't prioritized early.
Have these rates been changing over time? Are we making global progress against tobacco, or is it a losing battle overall?
There has been definite progress in relative terms, which is encouraging. Between 2007 and 2017, smoking rates did decrease across all income groups, low, middle, and high, with relative reductions of around 19%, 12%, and 20%, respectively. That's positive.
Okay, rates are going down.
And the projection is that by 2030, the global average smoking rate will decline further, maybe from around 19% now down to 16%. with significant gender disparity, though maybe 4% for women globally, but still 28% for men. So global anti-tobacco efforts like the WHO Framework Convention on Tobacco Control are having an impact.
But you mentioned a caveat earlier about the absolute numbers.
Yes, and this is the crucial, often overlooked point that really tempers the optimism. Despite these declining rates or percentages, the absolute number of tobacco users worldwide is still expected to rise in the coming years.
How could that be?
Simply due to ongoing rapid global population growth, especially in regions where smoking prevalence might still be high or increasing among men. So even if a smaller proportion of the world's population smokes in the future, the sheer increase in the total number of people on Earth could ironically mean more total smokers overall. It represents a persistent, massive public health challenge requiring constant vigilance and scaled-up intervention.
That's a critical distinction, yeah, that paradox again. And what about secondhand smoke? We often focus on the person lighting up, but does exposure to others' smoke significantly add to the CVD burden for non-smokers? Is it a big deal?
It's a huge deal. Secondhand smoke, or passive smoking, is a well-established and frankly insidious cause of cardiovascular disease. The scientific evidence is absolutely clear. Regular exposure to environmental tobacco smoke significantly increases the risk of heart attack and stroke for non-smokers.
How big an impact?
In 2017 alone, GBD estimated it was responsible for about 575,000 deaths among non-smokers globally. That's over 500,000 people killed by smoke they didn't inhale voluntarily.
500,000. Just from secondhand smoke?
Yes. And while comprehensive smoking bans in public places and workplaces have clearly demonstrated both immediate and long-term benefits, studies show drops in heart attack admissions soon after bans are implemented, for instance.
Right.
Their implementation and, crucially, their enforcement vary enormously between countries and even within countries. This means vast numbers of people, particularly women and children, and especially in many LMICs, are still highly vulnerable to this completely preventable cause of exposure and its devastating health consequences. Much more progress is needed on smoke-free environments globally.
Okay, beyond tobacco, diet is obviously a huge, constantly evolving factor. How does dietary change, especially the kind that comes with economic development and urbanization, impact CVD risk? What are the big global trends we're seeing?
Diet undergoes truly significant and often quite detrimental transformations as countries develop and urbanize. A general, almost universal trend is that total caloric intake per capita increases with economic development. People simply have access to more food, more calories.
More calories overall, but the type of calories changes too.
Drastically. And that's key for CVD. Specifically concerning cardiovascular risk, a major element of this nutrition transition is an alarming increase in the intake of saturated animal fats, more meat, more dairy, and critically hydrogenated vegetable fats, which often contain those industrially produced, harmful, atherogenic trans fatty acids.
Trans fats, right, the really bad ones.
They directly contribute to arterial plaque buildup. Simultaneously, there's often a troubling decrease in the intake of beneficial plant-based foods, fruits, vegetables, whole grains, legumes, and a shift towards more refined grains, like white bread, white rice, and simple carbohydrates, sugary drinks, processed snacks. These contribute to weight gain, insulin resistance, and metabolic dysfunction.
Can you give some concrete examples of these dietary differences?
Sure. Look at the proportion of calories coming from fat. In traditional diets in rural China or rural India, fat might contribute less than 20% of total calories. In Japan, traditionally, maybe less than 30%. But in the United States and many Western European countries, it's well above 30%, sometimes approaching 40%, historically much of it saturated and trans fat. That's a clear indicator of these dietary pattern shifts.
But you mentioned a potentially positive trend in HICs recently.
Yes, interestingly, despite these broad global trends towards higher fat intake with development, the caloric contributions from fat actually appear to be falling somewhat in many high-income countries over the last decade or two.
Really? Why?
It might indicate a positive shift in dietary awareness, maybe due to public health campaigns focusing on fat quality, clearer food labeling, or perhaps greater availability and affordability of leaner options or plant-based alternatives. So maybe some positive adaptation is starting to happen in populations that have been dealing with high CVD rates for longer. Still a long way to go, though.
Okay. And then the third big behavioral factor, physical inactivity. Yeah. It feels like a modern epidemic in itself, a silent killer perhaps.
Mhm.
How does that factor into this global health puzzle, especially as societies industrialize and automate?
Physical inactivity is a major, yet still often underestimated driver of the modern CVD epidemic. Absolutely. The increased mechanization that inevitably accompanies economic transition leads to this profound shift in work patterns. We move from physically demanding, often agriculture-based
Wait,
labor
farming, manual labor?
to largely sedentary industry and office-based jobs, desk jobs, service jobs. This fundamental lifestyle change, this engineering out of physical activity from daily life, is directly responsible for an estimated 1.3 million global deaths annually.
1.3 million deaths just from lack of movement.
Yes, it's a sobering figure. And while the overall global prevalence of physical inactivity remained relatively steady between 2001 and 2016, hovering around 28%, meaning more than 1 in 4 adults worldwide aren't meeting recommended activity levels.
That's still incredibly high.
It is. The problem is widespread and deeply embedded in modern life. In the United States, for instance, estimates suggest only about 20%, maybe 25% at best, of adults meet the federal guidelines for both aerobic and muscle-strengthening activity during their leisure time. The vast majority are falling short.
So even if the global average percentage is somewhat steady, it's becoming more prevalent in those rapidly urbanizing nations, suggesting a growing problem where it was once less common.
Precisely. Physical inactivity is similarly high now in many other regions, and it is demonstrably increasing in countries undergoing swift urbanization as part of their economic transition. The highest mortality rates directly attributable to inactivity were actually found in regions like North Africa and the Middle East, and in Central and Eastern Europe, places undergoing significant societal shifts.
Any specific examples?
A clear and concerning example comes from urban China. Studies there have shown that the proportion of adults participating in moderate or high-level physical activity has significantly decreased over recent decades, while simultaneously the proportion engaged only in low-level activity has markedly increased. The shift away from an active, often agrarian or manual labor-based lifestyle towards a more sedentary, urban existence is a powerful accelerator of CVD risk in these rapidly developing regions. It's a huge public health challenge to re-engineer activity back into modern life. So we've talked behavior smoking, diet, activity. But beyond that, our bodies respond to these societal changes in ways that dramatically impact our cardiovascular risk. Let's look now at the key metabolic factors, the internal biological responses. And we can draw heavily here from the comprehensive global burden of disease study data covering 195 countries from 1980 up to 2017. This helps us master the details of these internal risk factors.
Okay, the metabolic response. Let's start with lipid levels, specifically high cholesterol. We know it's bad, but what role does it play in actual CVD deaths globally, and what are the perhaps surprising trends we're seeing?
High cholesterol levels are estimated to play a really significant role in CVD mortality worldwide, contributing to about 4.3 million deaths annually.
4.3 million deaths linked to high cholesterol.
Yes. And to break that down, GBD estimates suggest it contributes to a massive 42% of all ischemic heart disease deaths, those heart attacks caused by blocked arteries, and about 9% of stroke deaths. So a huge driver, especially of CHD.
And the trends, do cholesterol levels just go up as countries get richer?
Generally, yes. I mean, population plasma cholesterol levels tend to rise as countries move through the epidemiologic transition, largely reflecting those shifts towards diets higher in saturated and trans fats and maybe lower in fiber. That's the broad pattern.
But I thought I heard global cholesterol levels were actually declining in many places. Is that still the case, or is it more complex than that?
It's definitely more complex now. It's become a story of two very different, diverging trends globally. Overall, between 1980 and 2008, the global mean serum total cholesterol levels did decrease slightly by about 0.08 millimoles per liter per decade in men and 0.07 in women.
Okay, a slight decrease globally. Where did the big drops happen?
The significant declines, really substantial drops of 0.19 to 0.21 millimole per decade, occurred primarily in regions like Australasia, North America, and Western Europe. This is likely a testament to public health campaigns about diet, the widespread use of statin medications, maybe reformulation of foods to remove trans fats. Real progress was made there.
But not everywhere.
Not everywhere, no, it's not a universal trend. During that same period, countries in the East Asia and Pacific region, for instance, actually experienced concerning increases in mean cholesterol levels, often more than 0.08 millimole in both men and women.
So cholesterol going up in East Asia while it was going down in the West.
Exactly. It highlights these critical regional differences, like likely reflecting different timings of dietary shifts towards Western patterns, maybe slower uptake of preventive medications, and just generally being at an earlier stage of tackling these risk factors compared to the HICs. Some regions are still accumulating risk, while others are actively combating it.
Fascinating divergence. And there's also a lot of buzz, emerging research on something called lipoprotein A, or LPA. It's related to cholesterol, but different. What's its significance, and why is it getting so much attention now?
Lipoprotein A, yes, often called LP little a. It's gaining significant attention as an important independent predictor of cardiovascular disease risk. It's distinct from your standard total cholesterol or LDL bad cholesterol measurement.
How does it increase risk?
It's a fascinating molecule because it seems to contribute to CVD through multiple potential mechanisms. It might increase lipid accumulation in artery walls, promote endothelial dysfunction problems with that inner lining of blood vessels, and it might even have prothrombotic effects, meaning it could increase the risk of blood clots forming.
So it attacks the system from multiple angles. How common is it to have high LPA?
Estimates suggest it's elevated, meaning at levels considered to increase risk in approximately 20% of the global population. That's potentially 1 in 5 people worldwide who might have this additional, often unrecognized genetic risk factor. Though, again, data from low and middle income countries are still more limited.
And does it vary by ethnicity?
There seems to be significant variation. Non-randomized data suggest higher rates and levels among individuals of African descent, maybe twice as high as Caucasians on average. While East Asians and South Asians seem to have intermediate levels, we need more research here, but genetics clearly plays a big role in LPA levels.
Can we treat high LPA? Yeah, there are drugs for it.
That's the tricky part currently. There are limited data right now on clinical agents specifically designed and proven to lower lipoprotein and reduce CVD events because they lower LPA. However, some existing medications, particularly the powerful cholesterol drugs called PCSK9 inhibitors, can significantly reduce LPA levels as a side effect. And this remains an area of intense research, with several new therapies specifically targeting LPA in late-stage development. So hopefully we'll have better answers soon.
Okay, moving on to another huge metabolic factor, hypertension or elevated blood pressure. You mentioned earlier it's often an early and sensitive indicator of the epidemiologic transition. Yeah. Why is that? What makes high blood pressure such a telltale sign of societal change?
Elevated blood pressure is indeed often one of the first major CVD risk factors to emerge and become widespread as societies transition. It's so closely linked to those foundational changes in diet, especially the massive increase in sodium intake from processed foods.
Salt, right.
Huge amounts of hidden salt, yeah. And also the significant reductions in physical activity that characterize the early stages of urbanization and modernization. As people move from active, often low-salt rural lives to more sedentary, high-salt, processed food urban existences, blood pressure levels in the population tend to rise quite predictably.
And even slightly elevated blood pressure matters.
Yeah,
Below the official diagnosis level.
absolutely. Observational studies have consistently shown a graded, continuous increase in cardiovascular disease risk, starting with systolic blood pressures as low as 110 to 115 mmHg. That's well below the traditional clinical threshold for diagnosing hypertension, which is usually 14E90. It strongly suggests that even blood pressure in the high normal range carries some additional risk over the long term. There doesn't seem to be a perfectly safe threshold above the very lowest levels.
And what did the global prevalence trends for hypertension tell us? Say, between 1990 and 2015, is it still a relentlessly rising tide globally?
Unfortunately, yes, for much of the world, the prevalence has increased. Between 1990 and 2015, the global prevalence of having a systolic blood pressure SPP of 110, 115 mmHg or higher actually increased from affecting about 73,000 per 100,000 people to over 81,000 per 100,000.
So more people crossing even that lower threshold.
Yes. And similarly, the prevalence of clinical hypertension, defined as SBP or 140 mmHg, also rose during that period from about 17,300 per 100,000 to over 20,500 per 100,000.
So what does that mean in terms of total numbers?
Well, in 2015, GBD estimated there were about 3.5 billion adults worldwide with SBP 115 mmHg. It's a huge number. Of those, about 874 million, or roughly 25%, met the criteria for clinical hypertension, SBP 140 mmHg.
Okay, so only a quarter of those with elevated BP meet the clinical definition. But do they account for most of the risk?
Disproportionately so, yes. That group with SBP 140 millimole Hg, while representing only about a quarter of everyone with elevated blood pressure, accounted for a massive 73% of all the deaths attributable to elevated SBP overall. That was 7.8 million deaths in 2015 linked directly to having SBP or 140. It really illustrates that while lower levels carry risk, the highest levels drive the vast majority of the mortality burden.
That's a striking statistic. How much of the total global CVD burden can be directly attributed to high blood pressure overall? What's its total impact on deaths from heart attacks and strokes?
It's immense. Worldwide high blood pressure is just a colossal driver of cardiovascular death and disability. GBD estimates that a staggering 55% of all stroke deaths globally and 55% of all coronary heart disease deaths are directly attributable to the effects of high blood pressure.
Over half of all heart attacks and strokes linked to high BP.
Yes, that accounted for a total of 8.25 million deaths in 2017 alone, just from high blood pressure. And the trend, again, shows that divergence between 1990 and 2015, the number of deaths related to SBP 140 milligd actually increased in all the low and middle income country groups, even as it fell in the high income countries, again highlighting the shifting burden and the growing challenge in developing nations.
So even with more awareness now, maybe more available treatments in some parts of the world, the sheer number of people globally living with uncontrolled hypertension is still growing. How is that possible if treatments are better?
That's correct. And it's another one of those paradoxes driven by demography. Between 1980 and 2008, the age-standardized prevalence of uncontrolled hypertension actually decreased slightly globally. That's a positive sign, suggesting improvements in detection or treatment effectiveness relative to age.
But the total number went up.
But the absolute number of people worldwide living with uncontrolled hypertension paradoxically increased during that same period. And it continues to increase. This is largely due, again, to ongoing global population growth and significant population aging. More people are simply reaching the ages where hypertension becomes much more common, even if the risk for a 50-year-old today is slightly lower than it was for a 50-year-old 30 years ago. The pool of older people is just so much larger now. Scale is the challenge.
And what about that rural-urban shift we discussed earlier? Does that clearly show up in blood pressure trends within countries?
It does, very clearly in many studies. Rising mean population blood pressure often occurs quite predictably as populations industrialize and move from rural areas to urban centers, adopting those new diets and lifestyles.
Any examples?
Yeah, for example, studies in India have shown the prevalence of hypertension in major urban areas can be as high as 33-34%, significantly higher than the 15% to maybe 30% seen in various surrounding rural regions.
Big difference.
And a major related concern, especially in LMICs, is the alarmingly high rate of undetected and therefore untreated hypertension. Millions of people walking around with high blood pressure who don't know it.
And that has consequences.
Huge consequences. This factor may explain, at least in part, why stroke rates are often higher relative to coronary heart disease rates during the earlier stages of the epidemiologic transition in some regions. High blood pressure is a potent driver of stroke. The high prevalence of undiagnosed hypertension throughout much of Asia, for instance, is thought to be a major contributor to the very high rates of hemorrhagic stroke, bleeding strokes seen in that region.
So detection and treatment are key. Any overall global good news on BP?
Well, despite these regional challenges and rising numbers, globally, the mean systolic blood pressure has actually seen a slight decrease for both sexes over the past few decades, about 0.8 millimole Hg per decade for men, 1.0 millimole Hg per decade for women. So, some interventions, maybe better treatment for those who are diagnosed, are having a positive, albeit slow, effect on the global average, but clearly not enough to counteract the demographic pressures yet.
Okay. Now to a metabolic risk factor that seems to be everywhere in the news and for very good reason. Obesity, or high body mass index, BMI. What's the global prevalence and trend for obesity, and how does it directly contribute to CVD?
The global obesity prevalence is alarming, frankly. Recent GBD data put it at 12.0% among adults worldwide, and worryingly, 5.0% among children. And it is unequivocally increasing worldwide, almost everywhere.
And faster in developing countries.
Yes, what's particularly concerning is that this increase appears to be occurring faster, with steeper trajectories in many developing countries compared to the path previously experienced by developed nations during their transition. It's like they're catching up, but much more quickly, often without the resources to manage it.
How does high BMI translate into deaths?
High BMI was estimated to contribute to 4.0 million deaths worldwide in 2017. That's about 7.1% of all deaths from any cause. And cardiovascular disease was by far the leading cause of these obesity-related deaths, accounting for 2.7 million lives lost. It was also the primary driver of associated delays, the disability-adjusted life years lost due to high BMI. Diabetes was the second biggest contributor. This just demonstrates obesity's profound direct and indirect impact on heart health, often acting through intermediate factors like diabetes and hypertension.
Are there gender differences in obesity prevalence? We hear a lot about that. Do women or men seem to be more affected globally?
Yes, there are distinct and quite significant gender differences globally, with women generally being disproportionately more affected by obesity than men.
Why is that?
The reasons are complex, likely a mix of biological factors related to hormones and fat storage, as well as socioeconomic and cultural factors influencing diet and activity differently for men and women in various societies. Looking at the trends, from 1975 to 2014, the global mean age standardized BMI increased more significantly in females, from 22.1 to 24.4 kilometers merge, compared to males, who went from 21.7 to 24.2.
So the average BMI went up more for women.
Yes, and consequently, the prevalence of actual obesity, usually defined as BMI over 30, increased much more dramatically in females during that period, rising from 6.4% to 14.9% globally, whereas in males, it rose from 3.2% to 10.8%. Still a big increase for men, but almost double the prevalence among women worldwide by 2014.
Wow, almost 15% of women globally classified as obese. And what about regional patterns? Where is obesity most prevalent and where is it less so? Does it track with wealth?
Country and regional differences are quite pronounced, as you'd expect. The highest prevalence of male obesity is generally observed in places like the United States, southern and central Latin America, Australasia, and central and western Europe regions, largely in stages 4 or 5 of the transition.
Okay, mostly developed regions for men and the women.
For females, the highest prevalence areas include southern Africa and North Africa, the Middle East, central and southern Latin America, and also the United States. So some overlap, but also some distinct regional hotspots for female obesity, particularly in the Middle East and North Africa and Southern Africa.
And where is it lowest?
The lowest prevalence for both males and females is consistently observed in South and Southeast Asia and across East, Central, and West Africa regions, often still in earlier stages of economic development and the nutrition transition, though rates are rising there too.
Is there a clear link with socioeconomic status? Does richer mean fatter, generally?
Generally, yes. At a country level, the prevalence of obesity for both sexes tends to increase as a country's socio-demographic index, a measure combining income, education, and fertility, improves. It follows that diseases of affluence pattern. However, it's worth noting that the rate of rise in adult obesity in the most developed countries seems to have slowed somewhat since around 2006, maybe suggesting saturation points or maybe public health efforts are starting to have a small effect at the population level there.
And you mentioned a paradox in LMICs.
Yes, a really perplexing and challenging paradox seen in many low and middle-income countries is the coexistence of obesity right alongside undernutrition and malnutrition, sometimes even within the same communities or households.
How does that happen?
It's often due to rapid dietary shifts towards cheap, readily available, highly processed, calorie-dense but nutrient-poor foods, while access to diverse, nutritious traditional foods might decline. So people can be overweight or obese in terms of calories, but still lack essential micronutrients. Adolescents seem particularly vulnerable in these transitional settings, setting them up for a lifetime of health challenges with both obesity and potential nutrient deficiencies. It's a complex malnutrition picture.
This leads us directly and logically to diabetes mellitus, which is so often a direct consequence of this increasing obesity and inactivity epidemic. What are the global trends for diabetes? Are they just as alarming?
They are absolutely just as alarming, if not more so, because diabetes is such a potent risk multiplier for cardiovascular disease. Worldwide rates of diabetes, overwhelmingly type 2 diabetes, are unequivocally on the rise, reaching truly epidemic proportions globally.
And it's driven by the same factors.
Yes, this surge is seen as a direct and predictable consequence of the increasing BMI trends and the decreasing levels of physical activity we just discussed, especially in those rapidly urbanizing LMICs undergoing the nutrition transition. The link is very strong.
How fast have rates increased?
According to the GBD project data, the age-standardized prevalence of diabetes increased dramatically between 1990 and 2017. A staggering 129.7% increase for males globally and 120.9% for females. That's more than doubling in less than 30 years. explosive growth.
Doubling. And what are the current numbers? How many people are we talking about living with diabetes now, and what's projected for the future?
It's a colossal number and growing fast. The International Diabetes Federation estimated around 476 million people worldwide had diabetes in recent years, and their projection is that this number will reach a truly staggering 693 million people by the year 2045 if current trends continue.
Nearly 700 million people. That's almost 1 in 10 or 1 in 11 people on the planet.
Exactly. And a major concern here is that nearly half, 50% of all people currently living with diabetes are estimated to be undiagnosed.
Half are undiagnosed.
Yes, meaning they aren't aware they have it, they aren't receiving necessary care or advice, and therefore they're at much higher risk for developing severe complications like heart attacks, strokes, kidney failure, blindness, amputations. It's a huge hidden burden.
And where do most people with diabetes live?
Compounding this, a disproportionate 80%, 4 out of 5 people with diabetes globally live in low and middle income countries. This places a massive, often completely unsustainable burden on already strained healthcare systems in those regions, further exacerbating global health inequities.
Are there particular regional hotspots for diabetes? Where is the prevalence and incidence rising most acutely?
Yes, some regions stand out. The Middle East and North Africa currently exhibit the highest regional age-standardized prevalence of diabetes, around 8.7% of the adult population. They also have the highest incidence rates, the rate of new cases appearing at about 400 new cases per 100,000 people per year.
Highest in the Middle East and North Africa. Where is it lowest?
In contrast, East Asia and the Pacific currently have the lowest prevalence, around 5.8%, and incidence around 249 per 100,000, perhaps due to different genetic factors, different dietary staples historically, or maybe just being slightly earlier in the obesity epidemic curve compared to the Middle East.
But where is future growth expected?
Despite these current numbers, the largest future growth in diabetes cases is projected to occur largely in the Middle East, across Africa, both North and Sub-Saharan, and in South Asia. It mirrors those trends in obesity and the ongoing accelerated epidemiologic and nutrition transitions happening in those regions. The rising rates of diabetes are essentially a ticking time bomb for future cardiovascular disease burden across the developing world.
Okay, we've covered behavior, metabolism, but beyond our lifestyle choices and how our bodies process fuel, there's another profound layer, isn't there? Our genes, our inherited blueprint. How much does that factor into this global heart challenge? Is it destiny or just another piece of the complex puzzle?
That's a great question, and it's an area of intense, really cutting-edge research right now. Scientists have invested a huge amount of effort in trying to understand how our genes affect cardiovascular health, both disease risk itself and the risk factors like blood pressure or cholesterol.
What have they focused on?
These efforts have primarily focused on identifying what are called germline genetic variants. These are basically small differences, variations in our DNA sequence that we inherit from our parents. They're trying to find which of these millions of tiny variations across the genome are related to specific CVDs or associated with levels of cardiovascular risk factors. It's like searching for tiny spelling differences in a massive genetic instruction book that might increase risks slightly.
And what's the current understanding? Have they found the gene for heart disease, or is it more complicated?
Oh, it's far more complicated than that. There's no single gene for heart disease. The number of associated genetic variants identified has increased meaningfully every single year, thanks to larger and larger studies like genome-wide association studies, GWAS. We now know of hundreds, maybe even thousands, of these common variants across the genome that are statistically associated with conditions like coronary artery disease or risk factors like LDL cholesterol.
Thousands of variants. How much risk does each one carry?
That's the key point. Each individual common variant typically explains only a tiny amount of the overall population variability in disease risk or risk factor levels. Think of them as very small nudges, maybe increasing your risk by 1% or 5%, not overwhelming pushes towards disease.
So no single gene is destiny.
For common CVD, generally no. Even when researchers combine the effects of many of these variants together into what are called polygenic risk scores, essentially trying to add up all the small nudges.
Right, get a total genetic risk estimate.
Exactly. Even these polygenic risk scores, while statistically significant and potentially useful for identifying people at higher relative risk, still explain only a relatively small amount, maybe 10–20% at best, of the overall variability of the disease in the population.
So genetics plays a role, but it's not the whole story by any means.
Not at all. It means that while your genetic inheritance definitely plays a role, it's often a complex interplay of many small genetic influences working together and critically interacting with your environment and lifestyle. Your lifestyle choices, diet, exercise, smoking still have immense power to influence your actual risk, regardless of your genetic background for common CVD. Genes load the gun, but lifestyle pulls the trigger, as the saying goes.
So still a lot more to learn then about how genes interact with environment, lifestyle, and how this might differ across different global populations.
Absolutely. We expect much more data to emerge in the coming years about these genetic associations, uncovering the precise biological mechanisms by which these variants actually influence risk. We need to understand relationships of variants that are specific to certain tissues, like the heart muscle itself, or the blood vessels, or the brain. And crucially, we need much more research on the complex interactions between genetic predisposition and lifestyle factors in causing disease. GXE interactions, they're called.
And the diversity issue. Is most research still based on Europeans?
That's another critical point, yes. It highlights a persistent and problematic bias in medical research. Currently, the vast majority of the genetic data we have for CVD comes from studies conducted primarily in populations of European ancestry.
So the findings might not apply equally well elsewhere.
Exactly. We know that genetic variation differs across global populations. Large-scale efforts are now finally underway to understand these gene disease and gene risk factor relationships in diverse global populations, people of African, Asian, Latin American ancestry. And the early data already suggests there are non-trivial differences in which variants are important or how large their effects are among various world populations. This highlights the absolute necessity for more inclusive, globally representative genetic research to truly understand human health and ensure that future genetic medicine benefits everyone.
And there's also something else beyond the genes we inherit, something related to aging and how our body's own cells can change their DNA over time. That sounds complicated.
Yes, that's correct. And it's a really fascinating, relatively newer area of discovery that links aging, cancer biology, and heart disease. Beyond your germline risk, the DNA you're born with, there appears to be increased cardiovascular risk associated with something called age-related clonal hematopoiesis of indeterminate potential, or CHIP.
Okay, CHIP, what is that in simple terms?
Don't let the jargon scare you. What it essentially means is that over time, as we age, some of our blood-forming stem cells in the bone marrow can acquire new genetic mutations, small errors in their DNA that weren't inherited as they divide again and again over decades.
So mutations happening during life.
Exactly, somatic mutations. Specifically, these can include loss-of-function mutations in certain genes that normally regulate cell growth or inflammation. Now, if one of these mutated stem cells starts to outcompete the normal ones and produces a large population, a clone of blood cells carrying that mutation, that's CHIP.
Okay, so you get a big clone of mutated blood cells.
Yeah.
Why does that increase heart risk?
That's the surprising connection. Even in individuals who develop CHIP but don't have any other signs of blood cancer or hematologic abnormalities, studies have found they have a significantly increased risk, maybe 40–50% higher risk of developing coronary heart disease or having a heart attack.
Wow, how? Do the mutated blood cells damage the arteries?
The exact mechanisms are still being worked out, but the leading hypothesis is that these mutated blood cells, particularly macrophages derived from them, might promote inflammation within atherosclerotic plaques in the artery walls, making the plaques more unstable and prone to rupture, which is what triggers most heart attacks. It's a truly intriguing area that connects the fundamental biology of aging, the behavior of our blood stem cells, and the long-term health of our cardiovascular system. Another layer of complexity beyond traditional risk factors. So we've covered a lot: the heart's energy, its limited repair, the stages of transition, the risk factors, both behavioral and metabolic, even genetics and aging. This preventable epidemic of cardiovascular disease clearly has staggering costs.
Yeah, you see it in the individual suffering, the devastating family impact, but also just the immense economic burden it places on nations, especially those trying to develop while facing this rising tide of chronic disease.
Exactly. But here's the crucial insight, the maybe more hopeful message. Understanding this concept of the epidemiologic transition, understanding precisely how societies tend to move through these stages and what drives those shifts, provides truly invaluable insight into how we can effectively intervene and alter its course.
So knowing the pattern helps us break the pattern.
Potentially, yes. It raises the most important question, really. Given everything we've learned about the heart's biology, the massive global burden, and the key drivers of risk, what can we actually do? What concrete strategies can lessen this impact? How can we apply this knowledge?
Right, that's the critical question. translating all this deep understanding, this mastery of the problem, into practical action. What are the key, maybe complementary strategies that experts recommend pursuing simultaneously to tackle this global heart challenge?
There are generally three main complementary pillars or strategies that need to be pursued together for maximum sustained impact. They work synergistically.
Okay, what's the first one?
First, and arguably the most foundational for long-term success, we need robust, comprehensive, population-wide public health measures. The goal here is to lower the overall burden of cardiovascular disease risk factors across entire nations, shifting the whole risk distribution curve.
How do you do that?
This means things like strong, sustained national campaigns against cigarette smoking, using taxes, bans, education, promoting healthier diets at a population level, maybe through food labeling policies, subsidies for healthy foods, restrictions on marketing unhealthy foods to kids, and critically, finding ways to encourage widespread physical activity across the entire population, safer streets for walking and cycling, promoting activity in schools and workplaces. These are broad strokes aimed at making the healthy choice the easy choice for everyone.
Okay, so broad public health campaigns hitting the big behavioral risks. But that won't reach everyone equally, right? What's the second strategy? More targeted approaches.
Exactly. That's the crucial second strategy. While population-wide measures are essential, it's also vital to identify higher-risk subgroups within the population, people who, because of existing conditions or multiple risk factors, stand to benefit the most from specific, often low-cost, prevention interventions.
Like screening.
Yes. This includes systematic screening for, and importantly, consistent, effective treatment of hypertension and elevated cholesterol. Finding those people with high BP or high cholesterol who don't know it, and getting them onto effective, affordable treatment. Think of it as a focused, strategic intervention for those most vulnerable or most likely to benefit quickly.
And finding simple, low-cost ways to do that.
Absolutely key, especially in resource-limited settings. We need to vigorously explore and implement simple, scalable, low-cost interventions. A really promising example that's gaining traction is the concept of the poly pill.
The poly pill? What's that?
It's basically a single pill that combines several essential evidence-based medications, typically low-dose aspirin, a statin for cholesterol, and one or two antihypertensive agents for blood pressure, all in fixed doses.
All in one pill.
Yes. The idea is that such a strategy could dramatically simplify treatment regimens, improve patient adherence because they only have to take one pill instead of 3 or 4, and potentially be manufactured very cheaply. It could make effective secondary prevention or even primary prevention in high-risk individuals much more accessible and effective on a massive scale, particularly in LMICs. Clinical trials are ongoing and looking quite promising.
That does sound promising. Okay, so population measures, targeted interventions.
Yeah.
What's the third strategy? Where should resources be allocated, especially when they're scarce?
The third strategy involves the strategic allocation of those scarce resources. We need to prioritize resources effectively. This means focusing on both acute interventions, things like having systems in place for rapid, effective treatment for a heart attack or stroke right when it happens, to save lives and minimize disability.
Emergency care, thrombolysis, stents.
Exactly. As well as prioritizing secondary prevention, investing in programs and support to help individuals who have already experienced a cardiac event, like heart attack or stroke, to prevent further events. This is often highly cost-effective because these individuals are at very high risk of recurrence.
So focus on acute care and secondary prevention first.
Often, yes, especially where resources are tight, because the immediate payoff in life saved and disability averted can be high. But alongside that, for countries with limited resources, a critical first step in developing any comprehensive CVD plan is simply getting better data.
Back to the data issue.
Yes, better assessment of cause-specific mortality and morbidity data, what are people actually dying from, and better surveillance data on the prevalence of the major preventable risk factors, how common is smoking, hypertension, diabetes in their specific population. You truly can't fight what you don't fully measure. Knowing the precise local burden and its specific drivers is the essential foundation for designing targeted, effective, and efficient public health responses.
So given all this, it sounds like the high-income countries, the HICs, have a particular responsibility here. They have the resources, the advanced science, and they've already navigated further through this epidemiologic transition. What's their role in the global fight?
They absolutely do have a critical role and responsibility. High-income countries must continue to bear the primary burden of research and development aimed at discovering and validating new prevention strategies and treatments. This includes developing novel drugs, innovative diagnostic tools, sophisticated medical technologies, and testing new public health models. They have the capacity for that cutting-edge R&D.
But they need to think globally when they do it.
Precisely. They must do so while being profoundly mindful of the significant economic limitations faced by many low and middle income countries, where 85% of the burden lies. Solutions developed primarily for wealthy markets and HICs often aren't directly transferable or affordable elsewhere.
So innovation needs to be appropriate.
Yes. Innovation needs to consider adaptability, scalability, and most importantly, affordability for widespread implementation globally right from the start. This might mean prioritizing research on robust, low-cost diagnostics and therapies or simpler delivery strategies, rather than just focusing on the most technologically complex or expensive interventions that might only benefit a small, wealthy fraction of the global population. It's really a responsibility to innovate for all of humanity, not just for the richest markets.
And ultimately, what's the overarching message then about knowledge transfer? About sharing the lessons learned during this transition? It sounds like the epidemiologic transition provides a kind of roadmap, but only if we share the directions effectively.
That's a perfect way to put it. The concept of the epidemiologic transition provides truly invaluable insight into how to potentially alter, or at least mitigate, the course of the global cardiovascular disease epidemic. It's a historical blueprint showing the path many countries have taken.
So we can learn from history.
We can and we must. The efficient, rapid transfer of proven, low-cost preventative and therapeutic strategies, those interventions known to work, those that are adaptable to different contexts, and critically, those that can be affordably implemented at scale in LMICs, this knowledge transfer could dramatically alter the devastating natural course of this epidemic in countless nations currently experiencing rapid rises in CVD.
Global solidarity in action.
Exactly. This glue in knowledge sharing, capacity building, and technical assistance is absolutely key to reducing the staggering excess global burden of preventable cardiovascular disease. It's about ensuring that the hard-won benefits of medical progress and public health triumphs don't just stay confined to wealthy nations, but actually reach everyone, regardless of where they live or their country's economic circumstances. It's about accelerating progress for the vast majority of the world's population currently bearing the brunt of this epidemic.
So after this deep dive, what does this all mean for you, our listener? We've really journeyed from the intricate, tireless energy processes happening right now inside your own heart muscle, dissecting those metabolic pathways, the fuel choices, the vulnerabilities.
Down to the mitochondria level.
All the way out to the sweeping demographic and societal shifts that are quite literally reshaping global health patterns right before our eyes. We've seen how the very fabric of modern human life, industrialization, urbanization, the food readily available, the jobs we do, our activity levels, even our genes and how we age, dictates the health of our hearts on this massive, almost unimaginable global scale.
It's daunting in its complexity.
It is. And it's clear that while the challenge of cardiovascular disease is immense, maybe the biggest health challenge humanity faces now, understanding these complex patterns, digging into the details, mastering this information, just as the elite professionals in the field strive to do, gives us powerful tools. Tools to not just react to the crisis, but to potentially, proactively shape a healthier future.
And this deep dive, I think, really shows us that cardiovascular disease isn't just a medical problem that's confined to the doctor's office or the hospital. It's a profound societal challenge, deeply intertwined with how we organize our societies, how we live, how we work, how we eat, the policies we enact.
It's everything.
Pretty much. The epidemiologic transition model highlights that progress is absolutely possible. We've seen proof in the dramatic gains made in many high-income countries over the past 50 years. But it also brutally underscores that such progress requires concerted, tailored, sustained efforts across all those different stages of development we talked about. A one-size-fits-all approach simply won't work for the whole world.
Right. Context matters.
Immensely.
Right.
And ultimately, it reinforces the idea that what we do today, both individually in our own lifestyle choices, the food we eat, how much we move, whether we smoke and collectively, and how we advocate for and support broader public health initiatives, research, and global health equity. All of it truly matters for heart health around the world, for ourselves, and for generations to come.
So here's a final thought for you to mull over as you reflect on all this. Think about the phase of the epidemiologic transition your own community, your own country seems to be in right now. Are you in a place still grappling heavily with infectious diseases, Or are you seeing that rapid rise of chronic conditions like diabetes and heart disease? Or maybe you're in that complex fifth stage, battling obesity while trying to maintain past gains.
What might that specific stage mean for the particular health challenges that you, your family, and those around you are facing? Or, perhaps more importantly, what opportunities does that stage present to improve health, both through informed personal choices and by supporting broader policy actions or community initiatives?
Because this isn't just about dry statistics or abstract global trends we discussed today. It's about the very real future of human health and well-being, unfolding one heart, one life, one community at a time. Keep exploring, keep learning, and keep asking those deep questions about the forces shaping health in the world around you.